Good day, ladies and gentlemen. My name is Muhammad Ali Yusuf, and today we shall be discussing genetics, human genetics. And the topic I decided to pick today is karyotypic syndromes. Karyotypic syndromes. When we say karyotype is the number, the sizes, and the arrangement of chromosomes inside the nucleus of a cell. The number of chromosomes, the sizes of the chromosomes, and the arrangement of the chromosomes inside the nucleus of a cell is referred to as karyotype. But karyotype is mostly restricted to the number of chromosomes. We say we have number, we have size, and we have arrangement, but it is mostly restricted to the number of the chromosomes. So we can say karyotype is the number of chromosomes in the nucleus of a cell of a particular species of organisms. When we say syndromes, syndromes are usually diseases that can be transmitted from parents to offspring. They are transmittable diseases. Diseases that can be transmitted from parents to their offspring. We call them syndromes. And these diseases are usually as a result of mutations, changes in the number of chromosomes, or changes in the number of genes, changes in the size of chromosomes or in the size of genes, or changes in the arrangement of chromosomes or in the arrangement of genes. So when we have changes in size, in number, or in arrangement of either chromosomes or genes that result to a disease, we call such a disease a mutation or a syndrome. Now, when we say karyotypic syndrome, they are diseases, transmittable diseases that manifest or that are produced as a result of changes in the number of chromosomes. Since we are dealing with the human chromosomes or with the human genetics, karyotypic syndrome is the changes in the number of the human chromosomes. Now, in humans, we have a total of 46 chromosomes, and these chromosomes are arranged in pairs. They are arranged in pairs, which means we have about 23 pairs of chromosomes. Total chromosomes in humans, 46. So these 46 chromosomes exist in 2-2, meaning in pairs. So we have a total of 23 pairs of chromosomes, which makes 46. Now, these chromosomes, we say they are 46 in number. Half of these chromosomes come from the father, and the other half comes from the mother. Meaning 23 chromosomes are from the father, and 23 other chromosomes are from the mother. That is why we have a total of 46 chromosomes. Now, these chromosomes have a unique size. This is a pair of chromosome. This is another pair of chromosome. And this is another pair of chromosome. If we assume this is the first pair of chromosome, this is the second pair, this is the third pair, this is how this chromosome continue up to the 22nd pair and the 23rd pair. So this is 22nd and this is 23rd pair. So this is how chromosomes are arranged in the nucleus of a cell. So this first pair is usually the largest, and this last pair is usually the smallest. So the first pair is the largest pair, and the last pair is the smallest pair. So from the first one to the last one, the sizes of the chromosomes decreases. Meaning this first one is larger than the second one, the second is larger than the third is larger than the fourth. Likewise, the 22nd is larger than the 23rd. So this is the largest and this is the smallest. The first pair is the largest, the last pair is the smallest. And remember, we say karyotype is also defined as the sizes of chromosomes in the nucleus of a cell. So in terms of sizes of the human genome, of the human genetics, The first one is the largest and the last one is the smallest. Now from the first pair to the 22nd pair of chromosomes in humans, they are called autosomes, or we call them somatic chromosomes. From the first pair to the 22nd pair, meaning about 44 chromosomes, are referred to as autosomes. Then this last pair, which is the smallest one, is called sex chromosome. Sex chromosome, or you call it gametic chromosome. Call it the sex chromosome or the gametic chromosome. So we have autosome and we have sex chromosome. So sex chromosomes are 2 in number, autosomes are 44 in number. So autosome plus sex chromosome gives us karyotype. In humans, autosomes are 44, sex chromosomes are 2. So the total karyotype of humans is 46. Now, these sex chromosomes, or this last pair, we have differences of these chromosomes when it comes to either male or female human. In male human, these last chromosomes are of different sizes. One is larger than the other one. But in females, they are of the same sizes. The first one and the second one are of the same sizes. So this is male human and this is female. So we say male, one is larger than the other one. In female, they are of the same sizes. Now the larger one in male is the X chromosome. The smaller one is the Y chromosome. In female, the first one is X, the second is also X. This is why in male we have XY and in female we have XX, because the two chromosomes in male are of different sizes. The larger one is X, the smaller one is Y. But in female they are of the same sizes and each one is an X chromosome. Okay. Now, we have seen the arrangement of these chromosomes, we have seen their sizes, and we have seen the differences between the sex chromosomes of male and female humans. Now, when we have mutation, or you call it trisomy, mutation or trisomy of a particular pair of chromosome, it leads to a syndrome or it leads to a disease. Meaning when we have a change in the number of a chromosome, we have a mutation or we have a syndrome. For instance, chromosomes are expected to exist in 2-2. 2-2. Chromosomes exist in 2-2, as we have seen. And we say in each pair of chromosome, one chromosome is coming from the mother and the other chromosome is coming from the father. That is why we have 46 chromosomes, 23 from father, 23 from the mother. Now, when we have 3 chromosomes at a particular point, instead of 2, we have 3 chromosomes. Because chromosomes are not expected to exist in threes, they are not expected to have 3 pairs. They are not expected to have 3 strands. So we refer to as trisomy. If we have a particular point where we have only one chromosome is not expected to exist as one. We call this monosomy. So each time we have a trisomy of a particular pair, or we have a monosomy of a particular pair, we refer to as syndrome or a disease, transmittable disease, or even you call it a mutation of chromosome. Mutation of chromosome. Now let's look at the karyotyping syndromes we have in humans. Okay, this is the first pair, this is the second pair, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th pair. This is 11. This is 12. This is 13. This is 14, 15, 16, 17, 18, 19, 20. This is 21. This is 22. This is 23. And we have 1. Now, if you look at these chromosomes, at this point we have 3 chromosomes instead of 2. At this point, we have 3 chromosomes instead of 2. Likewise, in this point, we have 3 chromosomes instead of 2, or we have 1 chromosome instead of 2. This is chromosome number 13. This is chromosome number 18. This is chromosome number 21. And this is chromosome number 23. Now, anytime we have trisomy at any of these chromosomes, we have a syndrome. At point 13, we have trisomy. You call it trisomy 13. At point 18, we have another trisomy, trisomy 18. At 21, we have another trisomy, trisomy 21. At 23, we have another trisomy, trisomy 23. Then we can also have a monosomy at 23. Now, if trisomy is 13, if we have trisomy 13, trisomy 13 is called Patau syndrome. Patau's or Patau syndrome. So this is the first syndrome. The second one, trisomy 18, we call it Edward syndrome. Trisomy 21, we call it Down syndrome. Trisomy 23, we call it Klinefelter syndrome. And the last one, monosomy, we call it Turner syndrome. So these are the karyotypic syndromes. We have 5 karyotypic syndromes. The first one is Patau syndrome, which affects chromosome number 13, meaning we have 3 chromosomes at chromosome number 13 instead of 2. Edward syndrome is trisomy 18, meaning we have 3 chromosomes at point 18 instead of 2. Down syndrome is trisomy 21. Now, Klinefelter syndrome and Turner syndrome both affect the sex chromosome because they affect chromosome number 23. So, if it is trisomy, we call it Klinefelter syndrome. But if it is monosomy, we call it Turner syndrome. So, we have Klinefelter syndrome at point 23. We can also have monosomy syndrome, that is Turner syndrome at point 23. So, these are the 5 karyotypic syndromes we have. Now, these first 3, if you observe, they affect chromosome number 13, 18, and 21. And chromosome 13, 18, and 21, they are part of the autosomes. So we call them autosomal syndromes. You call them autosomal syndromes because they affect their autosomes. Chromosome 13 is an autosome, 18 is autosome, 21 is also autosome. So because they affect the autosomal chromosomes, so we call them autosomal syndromes. But these last 2, Turner syndrome and Klinefelter syndrome, they affect chromosome number 23, which is a sex chromosome. So we call them sex syndromes. Sex syndromes. So based on this, we have 2 types of karyotypic syndromes. The first one is autosomal syndrome, and the second one is sex syndrome. Autosomal syndrome and sex syndrome form the karyotypic syndromes. We say karyotypic syndromes are changes in the chromosomes that result to a disease. So the chromosomes that usually change are chromosome 13, 18, 21, 23, and their names are they are named after the scientists that discovered these diseases. So Patau syndrome is trisomy 13, Edward trisomy 18, Downs trisomy 21, Klinefelter trisomy 23, and Turner syndrome monosomy 23. Okay. Now, Patau syndrome can affect male, it can also affect female. Edward syndrome can affect male, it can also affect female. Down syndrome can affect male, it can also affect female. But Klinefelter syndrome only affects males. Turner syndrome only affects females. Patau affects both gender. Edward, Down, they all affect male and female. But Klinefelter is a disease that only affects the males, while Turner syndrome is a disease that only affects the females. Now we say Patau syndrome is trisomy 23, meaning at 23rd pair of chromosomes, we have 3 chromosomes instead of 2. Had it been we have 2, then the total chromosomes will be 46. But because at this point we have 3 chromosomes instead of 2, meaning we have an addition of 1 chromosome to the total number of chromosomes, which is supposed to be 46. But because of this addition we have at point 13, then the total number of chromosomes of a person that has Patau syndrome will be 47 and not 46. Because 47 is for normal humans that have 2 chromosomes throughout. But a person with Patau syndrome has 3 chromosomes at point 13 instead of 2. So we'll have a total of 47 chromosomes instead of the normal 46 chromosomes we have. And this goes for trisomy 18 and trisomy 21. Each of these individuals will have 47 chromosomes in their total genome. Now, Klinefelter syndrome also has trisomy at point 23. So this person also will have 47 total chromosomes. But Turner syndrome that has monosomy 23, meaning instead of 2 chromosomes, this person has only 1 chromosome in the sex chromosome. That is the last chromosome. Instead of 2, he has 1. So instead of 46, we'll have 45 total chromosomes. 45 total chromosomes. Okay, now, in Patau syndrome, or Edward syndrome, or Down syndrome, which are all trisomies, remember, they only affect the autosomes. Meaning the chromosome that has increased in number is the autosomal chromosome. Now, normally karyotype we say is autosome plus sex chromosome. So their own is 47, meaning their autosome, instead of 44, it will be 45. Then their sex chromosome is 2. So we have a total of 47 chromosomes. Their autosome is supposed to be 44 because normal humans, their karyotype is 44 plus 2. This 44 is the autosome, this 2 is the sex chromosome. So we have a total of 46 chromosomes. But in individuals that have either Patau syndrome, Edward syndrome, or Down syndrome, they have an addition of the autosomal syndrome. So instead of 44 of the normal autosomes, they will have 45 to give them a total of 47 karyotype. But so we can say in individuals with either of these diseases, their karyotype is 44 plus XY for male, or 44 plus XX for female. This is male, this is female. Sorry, I mean 45. because they have addition of one autosome. So the karyotype of individuals with either Patau syndrome, Edward, or Down syndrome, their karyotype is 45 plus the sex chromosomes. We say the last chromosome is the sex chromosome, which is XY for male, or XX for female. But in Klinefelter syndrome, the individual has XXY as the sex chromosome. So this person has a karyotype of 44 plus 3. 44 plus XXY, which makes 47. So this one is 44 plus 3 and not 44 plus 2. This one is 44 plus 3 to give 47. But this one is 45 plus 2 because this one is affecting the autosome. But this one is 44 plus 3 because the syndrome here is not affecting autosome, it is affecting the sex chromosome. For Klinefelter, it is 44 plus 3. But for Turner syndrome, which has only one X in the sex chromosome, so this is, the karyotype will be 44 plus 1. That is 44 plus X, which is 44 plus 1 to make 45. So instead of having XX for female or XY, this individual has only X as sex chromosome. So we have a total of 44 plus 1 to give 45 karyotype. Okay, how do we come about this Klinefelter syndrome? Normally, or usually when we have XY parent and we have XX parent, XY is father or male parent, XX is mother or female parent. Now, ideally, when we have cross, this X is supposed to cross with this X to have XX. The same X will cross with the second X to have XX. This Y will cross with this X to have XY, and this Y crosses with this X to have XY. So we are expected to have 2 girls and 2 boys. That is a ratio of 2:2. 2:2 phenotype or genotype. This is for normal crosses. But in a case where we have Klinefelter syndrome, this father is XY and this mother is XX. Now, instead of this X to cross with this X will come along with Y. So we have XY linked together and is crossing with this X from the mother. So we'll have XXY instead of XX or only XY. Now, because of this linkage, because of this connection between the X and the Y that failed to separate during fertilization, we call this non-disjunction. Non-disjunction of paternal sex chromosome. When we say non-disjunction, it means the 2 chromosomes fail to separate during fertilization. So when the 2 chromosomes of the father fail to separate, it means both chromosomes will come in the sperm cell. So they'll fertilize the egg that comes with X from the mother. Then we have an individual that have XXY. This is called Klinefelter. Now this individual is a male because of the presence of the Y chromosome. Now we can also produce Klinefelter when we have non-disjunction of the female chromosome now instead of that of the male chromosome. If we have non-disjunction here, now instead of this Y chromosome to fertilize this egg, the X is supposed to come with only one X, but these 2 X will come and fertilize with this Y, because in this case it is the mother's chromosome that are connected to each other. They fail to separate. So we are still producing Klinefelter. We are still producing Klinefelter syndrome, but in this case it is non-disjunction of maternal sex chromosome. So the first case was non-disjunction of the paternal sex chromosome. In the second case is a non-disjunction of the maternal sex chromosome. So either non-disjunction of the male or non-disjunction of the female can produce Klinefelter offspring. So how do we produce Turner syndrome? Now, in the case of Turner syndrome, if we have non-disjunction of the paternal chromosome, now instead of these two chromosomes to come, then they will fail to come. Then only one chromosome will come from the mother to give an X offspring. So this is called a Turner syndrome. So this is a Turner syndrome that is produced as a result of non-disjunction of the paternal chromosome. We can also produce the same when we have non-disjunction of the maternal chromosome. Instead of this chromosome to come, they will fail to come. Then only this X will come and fertilize an empty egg. Then we'll have still a Turner syndrome. So we can produce Turner syndrome in either non-disjunction of the male or non-disjunction of the female. Likewise, the Klinefelter syndrome. Okay, now we have features or characteristics of individuals with these syndromes. Individuals with karyotypic syndrome. We have so many, but we will discuss only the similar characteristics. Now, either Patau syndrome, Edwards syndrome, Down syndrome, Turner syndrome, or Klinefelter syndrome, there are some characteristics of this patient or these individuals that are similar. One of the characteristics is infertility. Individuals with these diseases are usually infertile or sterile. Another character or another feature is they are usually they have hormonal imbalance or hormonal impairment. Hormonal imbalance or hormonal impairment. Another character is they have mental retardation. Another character is they have reduced or no secondary sexual characteristics. They have reduced or no secondary sexual characteristics like beards in male, like mustache, like breast in females. All these characters are either absent in these individuals or they are reduced. Another character is they have skeletal deformation. They have skeletal deformation. If you look at their structure is not a normal human structure. They either have deformation of the skull, you see their head is not as normal as humans, or they have deformation of their ribs, or deformation of their limbs. They usually have a deformation of a skeletal part of their body. So we have 5 similar features of individuals with either Patau syndrome, Edwards syndrome, Down syndrome, Turner syndrome, or Klinefelter syndrome. Another character, apart from these 5, is they have either additional or absence of some body parts. They either have additional body parts or they have absence of some body parts. Additional body parts or absence of some body parts, or even organs. They can have additional organs, they can have absence of some organs. It's another character of these individuals. This is number 6. Number 7, they have deformed sense organs. They have deformed sense organs. They can have problems with their eyes. They can be blind. They can have problems with their ear. They can be deaf. They have problems with their nose. They may not have smelling capacity. They may not have smelling capacity. They can have problem with their mouth or tongue, so they can be dumb, and so on. So this is another character of individuals with these diseases. So we still have other similar characteristics. So most of the times, individuals that have these syndromes, they usually have similar characters, though there are some unique characters for each disease. But usually the only way to diagnose or to differentiate between these individuals when it comes to identifying the particular disease is only through karyotyping. It's a laboratory test that is called karyotyping. In this test, you focus with a microscope into the chromosomes of the individual and be able to identify which of the pair of chromosome has been affected. If it is chromosome 13, then you know this disease is fatal. If it is chromosome 18, you know it is Edward. If it is chromosome 21, you know it is Down syndrome. If it is chromosome 23, and that chromosome has trisomy, then it is Klinefelter syndrome. But if it is the same chromosome 23, the last pair, but it has only one chromosome, then it is Turner syndrome. So you can usually differentiate these diseases only by a test that is known as karyotyping. That is using microscope to identify the particular pair of chromosome that has trisomy or monosomy, meaning the one that is affected. So these are the karyotypic syndromes. Now, still talking about how this Klinefelter and Turner syndrome are produced, because they are the commonest diseases. Klinefelter, Turner syndrome, that is after Down syndrome. Down syndrome is the commonest disease, then followed by Klinefelter and Turner syndrome. Now, usually when we have a drop of semen from male, drop of semen, I'm referring to the sperm of the male. Now, when we have a drop of semen or a drop of sperm in male, usually this drop of semen contains millions of sperm cells. Millions of sperm cells. A drop of semen, a drop of sperm, usually contains millions of sperm cells. Now, each of these sperm cells in male will either have an X chromosome or a Y chromosome. Either an X or a Y. Chromosomes are not expected to have both X and Y in sperm cell. So they are expected to have either an X or a Y chromosome. So now when we have a drop of sperm cell during copulation and we have an egg in female, the egg in female is expected to have only an X chromosome. So it is only one out of these million sperm cells that is expected to swim and fertilize this egg or this ovum in the female. Or we call it oocyte, as the case may be. So it is only one sperm cell out of this million sperm cells that is expected to fertilize only this one egg or ovum from the female. Now, This one sperm cell that will fertilize this egg is expected to have either an X chromosome, to have an individual with XX, that is a girl child, or the chromosome, the sperm will have a Y chromosome, and when it fertilizes this egg from the female, will have an XY, that is a boy child. This is the normal fertilization. Sperm cell plus ovum to give a zygote, normal fertilization. So the sperm cell is either a sperm that has only X chromosome or a sperm cell that has only Y chromosome. But the female egg usually have an X. The female cannot have more than X in the egg, meaning she cannot have a different chromosome apart from the X, because females usually have XX. So she can only produce an egg with X. That is to say, it is the male parent that determines the gender of the child, because the male parent can either produce an X chromosome or a Y chromosome, but the female can only produce X chromosome. Now, if female can only produce X with X chromosome, it means she has no say over the type of gender to be produced during pregnancy. So it is the responsibility, or it is by nature, the father that determines the gender of the child. If the father produces a sperm cell with X, then we'll have a girl child. But if the father produces a sperm cell with Y, we'll have a male child. So the sex determinant, the gender determinant of a child is the father and not the mother, please. Now we say this is a normal fertilization process. But what happens now when the sperm cell comes with both X and Y chromosome instead of only X or instead of only Y? Then we'll have a mutation. Meaning this will fertilize an egg that has X to produce a child that has XXY. This is how a Klinefelter is produced when we have non-disjunction of the male parent. Or a sperm cell comes with Y and fertilizes an egg that has XX, non-disjunction in the female parent. We still have XXY, which is the same syndrome, the same disease. This is non-disjunction of the male because it is coming from the sperm cell, and this is non-disjunction of the female because it is coming from the female egg, ovum. So this is the actual process of producing Klinefelter syndrome. Okay. When we have a sperm cell that comes without any chromosome, then it fertilizes an egg that has X chromosome. In this case, we will have Turner syndrome. We can have a sperm that doesn't have any chromosome, because this can come as a result of mutation, as a result of a disease. A sperm cell will come without any chromosome, but still it will fertilize the egg to produce a child with only one sex chromosome. That is Turner syndrome. Or we can have a sperm cell that has X chromosome, but in this case it is fertilizing an egg that doesn't have a chromosome. So in this case we are still producing X child. That is Turner syndrome. So we can have a Turner syndrome if the sperm cell doesn't come with any chromosome, or if it comes with an X chromosome but mates or fertilizes an egg that doesn't have a chromosome. But mind you, if we have a sperm cell with Y chromosome, it cannot fertilize an empty egg. The only sperm cell that can fertilize an empty egg, meaning an egg without sex chromosome, is only X sperm cell. But Y sperm cell cannot fertilize an empty ovum. That is why we don't have a child that has only Y chromosome. Now, when we have an egg or ovum from the female, usually it has X. Now, what determines the type of child to be produced, either male or female, is what sperm cell fertilizes the egg. Is it the X sperm cell or the Y sperm cell? If it is the X, we'll have a female child. If it is the Y, we'll have a male child. Then, why is it that at times pregnancy will have a male child, at times it will have a female child? It is based on which of these chromosomes fertilizes the egg, meaning which of these sperm cell fertilizes the egg. Now, we have some reasons that will make the X chromosome, the X sperm cell, fertilize the egg faster than the Y chromosome. We can have a situation that will warrant the Y chromosome of the sperm to fertilize the egg faster. We have conditions, we have reasons that can lead to that. For instance, when it comes to speed, the X chromosome is usually slow and the Y chromosome is usually fast. I'm talking about the X sperm and the Y sperm cell. The X is usually slow in movement and the Y is usually fast. When it comes to strength, the X chromosome is very weak. It's very strong, but the Y is very weak. When it comes to lifespan, the X has longer lifespan, about 2 to 3 days, even up to 5 days in some cases. But the Y chromosome spends only few hours. They even say maximum is 24 hours. It spends only few hours and it dies off. Lifespan, meaning X chromosome can stay up to 2 to 3 days inside the female body, but the Y chromosome cannot withstand the environment of the female body, so it usually dies within few hours after copulation. Another property is the acidity, the pH. Low pH high pH favors X, meaning alkalinity favors the X sperm, and low pH, that is acidity, favors Y sperm. So if the environment of the female has high pH, it will favor the X sperm. But if the system of the female has low pH, is acidic, it will favor only the Y. Meaning, if it is acidic, it will kill the X chromosomes and only favor the Y chromosome. But if it is basic, alkaline, it will kill all the Y chromosomes and favor the X chromosome. So when it comes to speed, the X sperm is very slow and the Y sperm is very fast. Meaning, if the two chromosomes, the two sperm cells are released at the same time, the Y chromosome would reach the egg faster than the X because it has a faster speed. It has a fast speed. So the Y is expected to reach the X before the X because it is faster. But if it comes to strength, this one is very strong and this one is very weak. Meaning, even though this one is faster in movement, because of its weakness, even when it reaches the egg, it is likely not to penetrate the egg because it is very weak. It doesn't have power to penetrate the egg as much as the X chromosome. It can reach the egg faster, but it may not have the strength to fertilize the egg. But this one that is very slow, it is very slow in movement, but when it reaches the egg, it can fertilize the egg faster than the X. So you see, we have advantages, we have disadvantages. One of the advantages of this is it can penetrate easily, but it is very slow in movement. One of the advantages of this is it is very fast in movement. It can reach the egg rapidly, but it is likely not to penetrate the egg because it is very weak in strength. Then the last one, this one can stay inside the womb, inside the body of the woman for some hours, then it dies up. But this one can stay for up to 5 days when the condition is favorable. It can stay up to 5 days, but the average is 2 to 3 days. 2 to 3 days. So now when we have sperm cells inside the female body, but we do not have an egg, meaning ovulation has not taken place, you see this sperm cell can stay inside the female body until ovulation, because it can stay up to 2 to 3 days or even 5 days. So even when it reaches the female body and the egg has not been released, ovulation has not taken place, it can wait for the ovulation to take place. It can wait for the egg to arrive and fertilize the egg. But you see, this one cannot wait. When it is after some few hours, it will die up. So it cannot wait for the egg. But the X chromosome can wait for the egg for up to 5 days. Now, talking about the pH, if the condition of the female body is acidic, if the condition, is alkaline, it will favor the X chromosome, meaning the Y chromosome may not likely stay in the body, it will die off because the condition is not favorable for it. But if the condition is acidic, then the Y can stay and the X may die off because the X chromosome cannot stay inside acidic body or acidic environment. Another very good 1, 2, 3, 4. The fifth one is gravity. X cannot move against gravity. X cannot move against gravity, but Y can move. So if a female is upright, then the sperm cell, if it is X sperm cell, it cannot move against gravity to fertilize an egg. It cannot move uprightly to fertilize the egg if the female is upright. And when it comes to the Y chromosome, even if the female is upright, the sperm cell that has Y chromosome can still swim against gravity. It can still swim upwards against gravity to fertilize an egg. So meaning if a female stands up, the possibility of fertilization is with Y chromosome and not X, because the X cannot move upwards, but the Y can move upwards. So that is that for karyotypic syndrome. Now, what makes this environment to be either acidic or basic? We have a reason. There are some type of food substances. That changes the pH of the female body. If a female individual usually eats food that have potassium-rich food. Potassium-rich food like fruits, like all these juices. When female is fond of taking food with potassium, this potassium will increase the pH. It will increase the pH of the body. No, it will decrease the pH, meaning potassium rich food will reduce the pH, will make it to be low. We need to make it acidic. So if the pH is low of the female body, so you see it favors only the Y chromosome, the Y sperm cell. But if the female is fond of taking food that are rich in calcium, like all these sweets, like milk, like yogurt, like egg, like chicken or meat, so to say. All these are food that are rich in calcium. So this type of food will make the pH to be high pH, and this will favor the X chromosome. So meaning foods that are high in potassium will favor the Y chromosome, meaning the tendency of having a boy child will increase if the female is fond of taking this food. And if she's fond of taking this calcium-rich food, then it will favor X, meaning tendency is to give birth to a girl child. So this is little about this topic, and when we meet next, we'll discuss a different topic.